Welcome to this KGH 51st edition, completely virtual, as you know. I hope you already enjoyed the first online meeting. And I would like to introduce you the topic of the day, which is humidification is health, and why especially it is important to humidify healthcare facilities and how should we do it in the best way. Today, I will speak together with my colleague Oscar.
Hello, everyone.
I am Luca Brotto, and I am area manager in the Central and Southern Europe branch office, especially dealing with HVAC products. And later on, my colleague Oscar will...
I'm presenting myself, yes. No worries.
Okay, before starting, I would like to make the point of the situation and why we think that the topic of this year is very important. We all know that during this pandemic, we are making big efforts to avoid spreading the virus. We use masks if we are at a short distance. We try to stay at home, not to go out, not to be in crowded places. But there are some very crowded places like hospitals where we have to try to decrease the risk of spreading the virus as much as possible. And this is very difficult in this time because we don't have enough hospitals and enough beds in the hospitals. This happens often. So what we can do is to make a little point of the situation of what has been the past trends. Sorry, I'm trying, okay. Share the screen. Okay. So today we are going to see why humidification is important and to give a perspective on what is, sorry, just need to. Okay. Thanks for the patience. I wanted to show you these brief pictures sum up for the trends of the hospitals in the past years from 1980 to 2000 basically. And this is a trend of decreasing the number of hospitals and decreasing the number of intensive care units, so the number of beds for acute illnesses. And this downwarding trend has been kept by countries and governments during the 2020 until now, basically. So it is very important to make new investments in hospitals. All the governments know this. So in the next future, we will see an inversion of this trend with new hospitals, with better efficiency systems, and the humidification systems will play a key role in this. Now I let my colleague Oscar explain you why, and thanks for listening to us.
Okay, so thank you, Luca. If you let me have the pointer, great. So welcome everyone again. I'll introduce myself briefly. My name is Andrea Oscar Frisiero. I work in the HVAC marketing unit commercial here in Carel. And in the next 30 minutes or less, even less, I would like to talk about this quite important topic for us. So let's start from the title. We wrote "Humidification is health," which is a quite interesting sentence. Let's start understanding why. For two reasons. Because it's always a good thing, I think, to start with why when dealing with a topic, but also because this matters. The knowledge of the relation between humidification and human health in general is not that widespread. So when we are dealing with our final customers, with the technical people, the technical directors inside the healthcare facilities, or whoever gives us some project to do inside the HVAC systems in a healthcare facilities, these people usually don't know much about this relation. So they need a bit to be taught in order for us to be effective. So that's why we want to spread this kind of knowledge. So, okay, humidification is health, we were saying. What health has to do with the humidity inside healthcare facilities? In order to understand that, we must start from one of the biggest issues that healthcare facilities in general can have, and that is healthcare-associated infections. What are those? You may think that a healthcare facility is full of infected people anyway, and you would be right. But with healthcare-associated infections, we mean basically those infections which patients catch while they are already in the hospital, while they are already being treated for another condition. Okay, so these are basically at the hospital's fault, okay, in some way. So this is the definition. They are quite a big problem all around the world, in any type of country. Just in Europe, these are a few numbers. There are 4.5 million healthcare-associated infections per year, 40,000 of which are deadly. A number which we can understand a bit better. At any point in time, 1 out of 18 patients inside European hospitals is there because of a healthcare-associated infections, because of an infection he shouldn't ever have caught in the first place, basically, if the healthcare system was, let's say, bulletproof. This number is even more impressive in ICUs, so intensive care units, which are those units which we are all running low in every country due to COVID. So 1 bed in 5 inside ICUs is taken by healthcare-associated infections. If we could free those places, there would be much more possibility also to deal better with pandemics like coronavirus. The most interesting number, 7 billion per year is the cost spread across all European hospitals to deal with these healthcare-associated infections. And these are direct costs. So costs that the hospital has to deal with, not even the cost for the society, like the missed workload of these people, or legal costs, or they are not even comprised here.
So, Oscar, basically
yes.
These costs could be cut some way, making better hospitals.
Yes, exactly. So these costs could be cut, making better hospital. This is really the point. By providing the tools, and we will see it briefly, to decrease this number of infections, we can have a payback for these tools. And it's not something very easy to calculate because, you know, of course, there is not such a direct correlation between, for example, humidification or a proper HVAC system and the decrease of these infections. The relation is there. It's just a bit difficult to catch. Okay, it must be explained, basically. So yeah, on one side we have this problem. Okay, these healthcare-associated infection. On the other side, we have another fact, which is that indoor environments, and hospitals are no exceptions, are too dry. This is a totally different thing. Why does it happen? It happens in winter, basically, because in winter you have very cold air outside, especially in continental Europe, okay? And you have still to get a minimum amount of recirculation to bring in oxygen, okay? You have to bring in outside air, and you have to heat it at least at 20 degrees or more in order for it to be acceptable. while heating outdoor cold air, you have that the capacity of it to contain water, which is the definition of relative humidity, increases a lot. The level of absolute humidity stays the same, hence the relative humidity drops. This is what we are seeing here within this psychometric chart. Maybe some of you are not technical, so the takeaway here really is that in this chart we are seeing the transformation from cold outside air to warm or comfortable inside air, and in this transformation we pass from having a high amount of relative humidity to being basically too dry. So we starting from these two facts, okay. So healthcare associated infection on one side and indoor dry air on the other side. Is there a correlation? Of course there is, because we are here because of this, okay. Actually, relative humidity, so humidification, is the climatic parameter that we as, say, technicians in the HVAC world can use to help fighting healthcare associated infections and the spread of airborne diseases like coronavirus. So this is really the main point here. Why is that? To understand that, let's take a look at how the infections occurs. So those healthcare associated infections we are talking about. So a large portion of those are through airborne transmissions. Coronavirus is through airborne transmissions. And so they all have in common, like influenza, coronavirus, SARS, any type of those illnesses, they all have in common this process here. So the infection again acts through air, and we can identify three different phases. So the growth of these microorganisms, so pathogens, the airborne diffusions, and the time, let's say, the time when these pathogens get inhaled by the new host. And in all these phases, actually, if we were controlling relative humidity, we could do something to stop and prevent this process from going through. So let's delve a bit deeper. So the relation between relative humidity and pathogens growth is somewhat intuitive, actually. We all know that we want to avoid too high humidity levels inside rooms, to avoid mold formations and bacteria colonies, and due to condensate formations, basically. So this is quite easy to acknowledge. But it's not really the point inside healthcare facilities. It doesn't happen anymore that these things, at least usually, it doesn't happen anymore that you have condensate formation on the walls inside healthcare facilities more often than not. It is important to stress out, but again, in hospitals, the source of pathogens is the patient itself, more than this kind of pathogens growth. But it was worth mentioning anyway. The real point here is airborne diffusion. The real point, the real factor where humidity and humidity control has something to say. Why? You all know, because it's really newspaper material, how respiratory diseases like coronavirus can transmit from one person to another. They go through basically respiratory droplets, which gets emitted by the sick people when it's coughing, sneezing, breathing, or talking. And basically, these respiratory droplets they float inside the closed environments, And yeah, they can stay suspended for a certain period of time. And of course, another person during this period, they risk to get affected, basically. So if we take average level of relative humidity inside the room, the behavior of these droplets is it's not so dangerous. They have a diameter of about 100 micrometer, and they can stay afloat for a few minutes. If the air inside is too dry, and really the threshold it has been discovered is about 40%, we have that they shrink a lot. Why? Because of course, to stay in equilibrium with the other with the air, the mass of water they are carrying basically evaporates, and they become much lighter, much lighter, and again they can stay afloat for much longer. 21 days is what the most recent studies found. 21 days is basically an indefinite amount of time, and the real issue here is that if the air itself is contaminated for such a period of time, any cleaning protocols you may use, it's basically useless, because even if you go to clean the walls, the beds, the handles of the doors, and so on, really the source of the contamination is the air itself, and you can't clean that with the conventional methods. So this is why this is really the main point. If you have to remember one thing about this presentation, I would say, please remember this one. Okay. Another still quite important thing is how our body reacts to the infection. Okay. To understand that, we have to understand what is the last defense mechanisms that we have inside our respiratory tract when we breathe air which is potentially infected. Okay, we have this thing which is called the mucociliary clearance. Basically, the walls of our respiratory tracts, so from the nose to our lungs, are covered in this layer of mucus, okay, which is constantly pushed upwards towards our mouth by the continuous movement of a huge amount of cilia or hair. What happens? When we breathe dust or pathogens or any impurities, they get trapped by this mucus layer. And the important thing is that they do not reach the lungs. And if the system works correctly, the moving action of this cilia brings this mucus towards our mouth, where it is digested, and basically it poses no threat anymore. What happens when we breathe dry air? A lot of bad things go on. Basically, the mucus is not sticky enough anymore. The movement of this air stops. The capacity, and this means the pathogens can go through it and go through the walls of our respiratory tracts. The capacity of our cells to regenerate the damage done decreases, and the production of interferons, which are certain proteins which helps stopping the replication of viruses and bacteria, also decreases. So really, the whole system, the whole defense system stops working. And that's why it's much more likely for people inside a dry, closed indoor environment. It's much more likely to catch something like coronavirus.
So this can be also one of the reasons why in winter we get more illnesses.
Yes.
Because there is more dry air, especially if you go outside, inside, the air is dry.
Yes, absolutely. That's the thing we mentioned before. So there is a seasonality in this kind of diseases. It is well known with influenza, but we are seeing it now that coronavirus is not that much different as far as seasonality goes, at least. And yes, this is definitely one of the main reasons. So indoor heated spaces are not very safe, basically, if the HVAC system is just heating.
Okay, thanks.
This is really the summary of what we discussed up until now. This is the Sterling chart from 1985, so really an old piece of knowledge, but it has been proved right again and again a lot of times during these years, and there have been many studies which have been made on this subject. What does it show? It shows that for our human body, the optimum, let's say, the optimum range of humidity to stay in, to thrive, is between 40 and 60% RH. Why? Because there you find a minimum of different risk factors, and these are the ones we talked about earlier. Okay. So I guess this is the second thing, if you have to remember, I would choose this graph here. So there are a lot of studies which have been made, and the coronavirus has spiked the interest on humidification topic, and even more studies are being made right now. Here, I don't want to bore you too much, just a little bit, and so I'm just presenting the few more relevant, okay, and the most recent, honestly. So this one was quite an interesting one from 2013. It was made in the US. They wanted to understand how influenza, okay, another type of respiratory disease, could spread inside a confined environment. Basically, they had these two mannequins, one which was simulating a coughing person, and the other one which was simulating a person breathing. The coughing was infected with some influenza virus, and they could see the infectivity of the air which was breathed. They analyzed it, varying the relative humidity in the room. And that curve is the result. You can see a sharp decrease in infectivity from 80% to something like 20% as soon as a minimum threshold of relative humidity is passed, and that is 40%. This is already a quite significant proof, I would say. This next one was, I think, even more interesting. So this study from 2016 was done in an American hospital. Basically, they had no humidification inside. What they did was monitoring 10 patients' room for quite a lot of time, for 1 year, basically, even more, actually. And they really monitored all the different parameters that they could catch. So, of course, temperature, relative humidity, but also like illumination and airflow, percentage of fresh air, level of some pollutants like CO2, VOC, really all the HVAC parameters you could think of, and not only. And what they did was they also monitored and analyzed the number of healthcare-associated infections that people which were being treated inside these rooms caught. And from a mathematical point of view, they found out that the parameter, the HVAC parameters with the most correlation, inverse correlation with the number of healthcare-associated infection was relative humidity. There was an inverse correlation. This is the graph which shows it. The red bars are the infections. The blue level, the blue line is relative humidity. In summer, when the indoor spaces were not heated, humidity was good. It was above 40%, and you had a number of infections from 0 to 2. In winter, with drier at least indoor spaces a bit below 40%, the number of infections went to above 10, about 10. So not a small difference. And again, really, this was found from a mathematical point of view. Relative humidity was the parameter with the most correlation. Last one. This is about coronavirus, and the results are pretty similar also for coronavirus as for influenza and other airborne transmitted diseases. So again, coronavirus is still basically developing. So we do not have many studies right now, but what we can tell from what we have is that the influence that relative humidity can have on other airborne transmitted diseases can be realistically applied also to coronavirus. It can be said. So this study here it was made in Australia, and they basically covered the whole period of ascending and descending phase of contagion, basically around March, April, midsummer. They analyzed within a certain region, New South Wales, I think. They analyzed the number of cases and the number, the climatic conditions they had in these regions in the period of days immediately before those cases were basically detected. Okay, and again, from a mathematical point of view, they analyzed a lot of different climatic parameters. Okay, so wind, temperature, rainfall, and relative humidity. From a mathematical point of view, they found out that relative humidity was the most related. So when relative humidity went down, there was an increase in cases by 7-8% after a few days. So this part was the most important, I think. I mean, we saw the physical explanation and we saw some analytical proof. If we needed more, okay, if the customer is still not convinced why he should install a humidifier, there are other reasons to bring out. Not the most important compared to what we saw, but there are. So there is something to be said about electrostatic discharges inside healthcare facilities, for example. These are basically a phenomenon which can occur when, due to friction, some electrostatic charge gets applied to a certain item or person, and then it can be discharged instantaneously if this person or this item gets touched. Basically, we all know it. We all know this thing. I'm making it more difficult than it is, probably.
And when it is happening, usually when it's winter.
In winter, yes.
Winter and with trial.
Exactly.
It happens to me many times. Not today that it's raining actually, but usually.
Exactly. Rain helps, but we can't count on it. So the thing in healthcare facilities is that it can damage badly some costly and fundamental medical equipment. Okay, because some electronics basically is very sensitive and delicate in this regard, and relative humidity can help. Of course, the units, the medical equipment units, has to be built with ground connections and so on. But if air is too dry, this phenomenon occurs. If air is humid enough, basically these charges get discharged gradually through the air itself. That's what happens, and why when basically the air is humid enough, it's much less likely to run into this issue. And then, of course, there is something to be said about comfort. Really, it is probably the last thing in healthcare facilities, but not elsewhere. we have that relative humidity can affect how we feel, okay, our comfort. It affects the perspiration of our skin, our skin and eyes dryness. It can prevent something which is known as a sick building syndrome, which is a syndrome which can be developed in buildings for prolonged exposure to buildings where the HVAC system doesn't work properly, basically. And also something to be said, a proper relative humidity level has also an influence on productivity. So the workers, the medical staff inside the healthcare facilities, and of course for the things we saw before, it lower the absenteeism rate.
Especially because people is less sensitive to illnesses, so basically don't stay at home.
Exactly. How many times has it happens that, I mean, your colleague has sneezed in the office 10 meters away. No, I hope not the COVID, but maybe influenza, it has happened.
Yeah.
Yes, so there is also this aspect to be said. What do we do really to counter all these things inside the healthcare facilities? It must be said that usually certain areas of the hospital are, let's say, correctly at least monitored. So in the operating theaters, usually we do monitor temperature, relative humidity, and a lot of other things, and that's good. What's not good is that all the rest is honestly often neglected. So we have, of course, a thermostat because that's the bare minimum, but everything else a lot of times is not there. While in all the areas of the hospitals, really considering the role that relative humidity can have for the process of the hospital itself, which is healing people, really in all the other areas of the hospitals, we should have also proper humidity control. So wrapping up, already said it, this is the main takeaway here. For our health, for our human body to thrive more than being comfortable, we have to stay in an average range of humidity, okay, in the air. So it's an average range in the middle. It's not too difficult to reach, but again, it's not there, for example, in the winter season. So yeah, and this is necessary for the very process the hospital is being built in the first place, okay? So it should be seen not only as a cost, but really as an opportunity to improve the performance of healthcare facilities and to generate a payback. Because we saw it in the beginning, billions are being spent yearly because of healthcare-associated infections, which can be prevented also with methods like this. So what are the next steps? Check, first of all, if our rooms, our indoor conditions are within that range or not. Okay, so monitoring or at least understanding if the most important factors are out of bounds is for sure the first step. And then ensuring that there is a proper humidification system to do the relative humidity control.
And given the opportunity to build new hospitals in the next future and to increase the efficiency of all the existing ones, I think that targeting humidification will be very important. And in fact, I would like to continue the presentation with some technical suggestions regarding this this way to humidify, how to humidify correctly the environments inside healthcare facilities, targeting especially adiabatic solutions. So, what is your opinion? Is adiabatic humidification safe? Usually we say yes, it is safe, but sometimes for healthcare facilities the answer is no. Why it is known? We will see it. Do you use it in your country? Here as well, depending on the norms, there are different approaches, and some kind of humidification products can be used, some others not. There is a norm called VDI 6022 that probably you already know, which helps us to decide if a humidifier is hygienic or not. If some HVAC product like an air handling unit is proper for healthcare use application, for example, for an hospital, for an operating theater, or for normal rooms for patients. And this VDI is a norm for ventilation and indoor air quality, giving guidelines for hygiene requirements, especially for HVAC systems. Where VDI, just to remember it, is the German way of saying German Association of Engineers. VDI is a norm existing for a very long time, more than 20 years, that describes the state of the art, so the best hygiene and air conditioning systems characteristics. It defines the planning, the construction, the operation, and the maintenance. So the overall steps, all the steps that must be taken care of for HVAC systems. And it is used also to plan the inspection and the service of the units when we go to the field and we perform the maintenance. That depending on what type of product has different timings and different requirements. The target of this norm, the VDI 6022, is to protect individuals. So basically, from the start, the very start, we plan, we think of the products, we design them with the purpose to make better systems, more efficient systems, especially the hospitals. Last update has been in January 2018, so this is just to say that this norm keeps being updated, and who is following this norm is providing the best class solutions. Do you use it? You can type it in the chat, for example, here. I would like to see if you are actually making design respecting VDI 62 or not. Why do I ask this? Because there are some countries that use it. It is mandatory in Germany, Austria, and Switzerland, while the rest of Europe use it as a guideline. So all the products usually are sold internationally and tend to respect the best norms, like Euroband, for example, for efficiency, VDI for hygiene. And for this reason, many associations, for example, for air handling unit manufacturers and the air handling unit manufacturers themselves use VDI 6022 to build correctly their units, and often also to certify them.
So Luca, sorry, let me understand. So you're saying that it is okay, absolutely a law requirement in certain countries, but in certain others, I understand that it's still a technical reference, and it is what it is being, let's say, looked at if we were to understand if an HVAC system is hygienic or not.
Yes, exactly. This is exactly this. Some countries are more advanced in this hygienic topic and define these kind of norms where we can find all the answers to good design, good maintenance for such units. The rest are accepting this standard and developing their own or basing directly on these standards that are used also in the European Union for common rules. So VDI 6022 gives some technical, real suggestions. So a humidifier, in this case, must have a good feed water as a starting point. So if we are using a steam humidifier, the water must be clean, must be drinkable, potable. If we are using adiabatic humidifiers, the tendency is to suggest the mineralized water, at least partially. We will see why. All the materials and the concept of the humidifier must be corrosion resistant, first of all, easily cleanable, and with materials that do not allow the growth of bacteria and microorganisms, which can be really dangerous for infections. Because if you spray water in an environment with something bad inside, this is in the air and can be inspired by people, especially in the hospitals where we want to avoid this. Using adiabatic humidifiers, we have a really strong suggestion in using droplet eliminators, so avoiding to let water end up on equipment inside the handling units. So we must stop the water in the humidification chamber and drain it to the pan and take it away in order to spray only clean water and do not make the water stagnate and cause some proliferation of bacteria, for example. All of you know for sure the Legionella bacteria, which is really dangerous for our health and cause something similar to pneumonia.
Yes.
Like COVID, but different bacteria and virus. So, first thing that we learn from VDI 6022 is that even if it's not written in the stone, it is suggested not to use recirculation or wet media humidifiers for such application like hospitals, where hygiene is a must. Something that is suggested for humidifiers is the use of UV lamp that helps decreasing the bacteria content in the water with continuous use of ultraviolet light that kills the microorganisms. Regarding the service, we know from VDI 6022 that isothermal humidifiers are intrinsically safe, so they can be used everywhere, also in the operatory theaters, where the conditions must be stable and top hygiene. Why? Because the steam is normally at 100 Celsius degree and kills all the bacteria and viruses inside the water. More than this, isothermal humidifiers are easy to maintain, even if need frequent maintenance, as most of you already know. But VDI 6022 says that this kind of humidifier is absolutely okay for hospital application, for example. But also adiabatic humidifiers, if they have intelligent controls and are advanced enough, can be used for hospital application, especially if they do not recirculate water, if they have hygienic materials, if they use the mineralized water, and if they are maintained often. We will see a little better what is the kind of maintenance that must be done on these systems, because in some of them is even less than isothermal systems. Something that VDI implicitly says, but it's not written in it, because it really depends on how you make maintenance on humidifiers, is that if you want to use recirculation, or if you want to use materials that are very good for bacterial growth, like porous materials, like paper or some kind of plastics that are used often in wet media humidifiers, for example, you must do very strict controls every 2 weeks or every month in order to ensure the humidification section and the air after the humidifier are clean and not risky for the patients or the people in the building. So you can use these humidifiers if you want, but you know that it is your responsibility to keep it safe, because it could become not safe really easily. Regarding the adiabatic humidifiers, I would like to sum up and remember you that there are minimum requirements in the VDI, but VDI is also the base for certification. So you can find adiabatic humidifiers that are certified, and you will see that most, basically all the isothermal humidifiers are not certified, because isothermal are safe, always, basically. And adiabatic humidifiers, if are certified, are for sure safe, if you do the correct maintenance. Otherwise, it is very dangerous to use some kind of humidifiers that can be dirty, where you do not make the correct maintenance. So, certified means safe, and also safe designer, safe manufacturer of humidifiers and units. And we are covered. We know that application will be.
So I think this is the most important slide, right?
Basically, the last line of this slide is very important. If you have any question, for sure, feel free to text it in the,
yes.
in the chat.
Yeah, exactly. Probably we didn't see it, say it earlier. Feel free. Anything you want to ask, to type it in this chat.
So regarding our products, Carel humidifiers, and taking the most interesting one, in my opinion, because it is used in some countries where VDI is applied, and it is not used in some countries where the VDI is not applied, for a good reason. Because adiabatic humidifiers can be safe or not. It depends on the design, it depends on the maintenance of it. But it is for sure safe if it is certified. If it is certified, VDI is like it is. Why is it certified? Because it uses the mineralized water. It has approved materials like stainless steel AZ304 and approved plastic materials that have hygiene certification. Then we have a stainless steel drop separator, which is mandatory in all of the hospital applications to be in to be present, first of all, and to be also in material good for avoiding micro biological substances. We can provide the design suggestions, as we'll see later, that avoid having troubles in such units. And we have software logic fully automated for avoiding dangers, health dangers in the use of a humidifier. We have the possibility to connect a limit probe for the management of the humidity after the drop separator to avoid condensation after the drop separator, because there should be no water after this part of the system. We have drain and washing cycles every 48 hours, mandatory to keep all the water line clean from the water treatment to the spray. We have warnings and alarms that are not mandatory, but are always useful to understand what is the situation, and possibility to connect to a DNS. Carel, not Carel, speaking also with the manager of the service to improve the quality of maintenance. And something that is not mandatory but is optional for safety is also the possibility to have a backup of the humidifier automatically. That switches the production from one humidifier to the backup unit, and this allows continuous working 24 hours per day during all the year. Also when you need to make maintenance and you should stop one system at the other. All these characteristics give us the VDI certification for hospital application, clean room application, and very strict hygiene requirements. Regarding design suggestions, thanks to our tool online for design, you can see here the link, for example, for accessing. We can tell you already what is the best setup of the humidifier, the reverse osmosis system, but also the rack spraying the water inside the air handling unit. Regarding this, we have to pay attention to some things that are very important. First of all, the installation of the drop separator, which must be a little bit with slope to let the water be drained in a better way, and with frontal sealing, so must be all closed around on the walls of the air handling unit to assure the fog to hit the drop separator and not bypass it, because it is very dangerous to wet after the drop separators, like the filters. The filters are the best part of a system to grow bacteria if they are wet. As you know, they are usually made in textile. So textile is best for growing molds, bacteria, and so on, if it is wet. Again, materials are very important. So the lowest requirement is usually stainless steel 304 that has a surface, a really flat surface that ensures the cleaning, self-cleaning, basically nothing, no bacteria will grow on it. The availability of draining pens and the good design of this draining that ensure no water will stay stagnant in this section. A good absorption distance that we usually suggest to designers with our tool that allows to spray only the required amount of water and not spray a lot of water that will create good conditions for bacterial growth, basically when you have very high relative humidity in this section. And you know that this water must not be recirculated. So if you spray only the minimum required amount of water and you do not recirculate this water, it means that all the water you spray is absorbed and you don't waste it in the drain. So it is efficient thinking. In the end, just to remember you, is the limit probe that must be installed at the end of the system after the drop separator to avoid the relative humidity growing over 80% usually, relative humidity level. So a correct design avoids troubles in the air handling unit, like especially residual fog condensation after this section. Just to close, I would like to suggest you to check our booth. You can see it on the left here, at print screen of our booth, where you will find some interesting brochures, especially this one, the success story of the hospital where we first installed our adiabatic humidifiers in Italy, in France in this case, but there is also another one with Italy. And there are also a lot of references that you are able to see on this new website that my colleague is managing mostly, healthcare.carel.com, where you will find some suggestions regarding hygiene, green use of our equipment, indoor air quality, and some more details about where our humidifiers are installed. For example, here I would like to say, but I'm in Italy, in Serbia, in Niš hospital, where we have this kind of humidifier working, humifog, adiabatic humidifier. And you will see also white papers for hospitals and success stories. If you would like to make some questions, the time is over, so please stay here. We will be available for answering any questions. And thanks again for listening.
Thanks.
Thanks a lot. So I would like to check if you can use this chat. If you have any questions, please type them here. And thanks again for attending.
We see a couple of minutes, I guess.
Yes, we can wait a couple of minutes. There were a lot of people online with us.
Hope the audio was good, but so yes. I think so.
Okay, I think that everything was really clear because all of you, more than 40 people were attending, and there is no question. So I hope that you will visit our booth where you will find the possibility to chat with me and my colleagues and see all the material we uploaded, like in a real exhibition, but virtually this time, all safe at home. Okay.
Okay, so thanks also on my behalf, and yeah, see you in Carel virtual booth or at KGH next year, maybe.
Hopefully, definitely. Thanks a lot. Bye-bye.
Bye.